So hi guys, we have learned a couple of things about the structure of the periodic table. We now know that it is arranged in rows and columns which signify periods and groups. We praised it particularly as a special table that enables us to predict several properties of elements. But so far, have we been able to predict anything? Do not worry. In this quest, we will learn how to understand the trend of certain physical properties as we move across the periods and down the groups of the periodic table. We will start with the property called atomic size. Now, atomic size basically refers to the size of an atom. It is often called the atomic radius, and it gives the distance from the center of an atom to its outermost shell. In the case of molecules, the atomic size may be given as the distance from the nucleus of one atom to the nucleus of the other atom, while its atomic radius, which is half of the atomic size, is half the distance between two nuclei of a diatomic molecule. To understand the trend of atomic size in the periodic table, let's use group 1 of the periodic table to note the group trend. In group 1, the first three elements are hydrogen, lithium, and sodium. Hydrogen has 1 electron, so its shell diagram looks this way. Lithium has 3 electrons, so its shell diagram looks this way. While sodium has 11 electrons, so its shell diagram looks this way. Looking at these atoms, what can you say about the trend of atomic size down the group? Obviously, as we move down the group, even as the number of electrons in the outermost shell remains the same, more shells are added to the atoms. This increasing number of shells as we move down the group translates to an increase in the atomic radius of the atoms. The hydrogen atom having just 1 shell has the smallest size. The sodium atom having 3 shells has the largest size, while the lithium atom has a size that is larger than that of hydrogen but smaller than that of sodium. This means that we can say for a fact that atomic size increases as we move down the group on the periodic table. Let's now see the trend of atomic size across the period. To do this, we will use some elements in the second period of the periodic table, particularly carbon, nitrogen, and oxygen. Carbon has 6 electrons, so its shell diagram looks this way. Nitrogen has 7 electrons, so its shell diagram looks this way. While oxygen has 8 electrons, so its shell diagram looks this way. The trend of atomic size in this case is not as obvious as with the group trend. However, a simple analogy will enable you understand this better. Let's assume that we have 2 very small magnets, 5 cm apart. Do we expect them to attract? Of course not. Now, what if we place these 2 large magnets at that same distance? Definitely, there will be an attraction. Let's see how this can be likened to the atom. You remember that the atom contains positively charged protons which are embedded in the nucleus. Now, these protons, being positively charged, attract the negatively charged electrons on the outermost shell of the atom. For carbon, there are 6 protons attracting the 4 electrons on the outermost shell. For nitrogen, there are 7 protons attracting the 5 electrons on the outermost shell. While for oxygen, there are 8 protons attracting the 6 electrons on the outermost shell. Now, just like our magnets, the atoms with larger charges will have a greater nuclear attraction. So, the oxygen atom will appear to shrink more than the nitrogen atom, which in turn shrinks more than the carbon atom. This increased nuclear attraction helps us understand that as we move across the period from left to right, the radius of atoms decreases. In summary, as we move down the group, the atoms increase in size because more shells are added. But as we move across the period from left to right, the atoms decrease in size because of an increased nuclear attraction. And lastly, by increased nuclear attraction, I mean an increased attraction of the positively charged protons and the negatively charged electrons on the outermost shell. I'll see you in the next lesson.